Hi guys, good evening everyone. Welcome to the class. Welcome to the India's most comprehensive preparation platform, that is the BYJU'S exam prep. Okay. Alright, hope you're all doing good. Let's get continued with our previous year questions discussion for the years of previous year questions discussions for the year of 2021, 2022 and 2023, and we are discussing signal and system. Already on Friday I have discussed the signal and system questions for electronics. Okay, today we are discussing it for electrical, but since it is a common subject, I always keep suggesting the students, it is a common subject, so you should practice the questions of all branches, and that is why I'm bringing you for all branches but separately. Okay, whether your branch is EC or EE or instrumentation as well, you can attend this particular session because you're going to get a good question variety for practice. Good question variety for the practice. Okay, right, so signals and systems. Okay, signals and systems. Let's get started guys. Hope you're all ready. Hi, good evening everyone. Good evening Harihar. Okay guys, so this is a regular introduction. Okay, so guys, for the PDF of today's class, like even last session's PDFs I have shared you, the today's PDF, and other than the today's PDF or for discussing of doubts or important updates about the upcoming exams and anything, you can be connected in my Telegram group. The link is mentioned here. I'll share it in the chat box also after some time. Okay, so the UPSC ESE results have already been declared and it's the interview going on. Okay, phase 1 interview already started, you're almost completed. Phase 2 interviews are going to start in October. So if you're one of them, okay, who are going to appear for the ESE mains interview and you're looking for free mock interview guidance, and not only guidance, your mock interview conducted, okay, by a panel phase 2, one-on-one, phase 2 phase, so that you know you're really prepared for the interview before the actual interview. Okay, so you can just participate in this. There's a link in the description. Share your results and the team will contact you to book your slots accordingly. Now guys, time to get started with the question eventually. 2021 EE 1 mark question. Okay, 2021 EE 1 mark question. Okay, so very basic fundamental question here. There will be some good questions also. There will be fundamentals as well. Two discrete time linear time invariant systems with the impulse responses H1n and H2rn corrected in series. Okay, where delta n is the Kronecker delta, or that is a regular impulse function, you can say. What is the impulse response of the cascaded system? What should be the impulse response of the cascaded system? The impulse response, whenever two systems are connected in cascade, the impulse response is basically given by H1n convolution with the H2n. Simple. Okay, the impulse response, two systems are connected in cascade, so the impulse response are what? It is convoluted. Okay, so it's a very basic convolution because it is involving what? It is involving the impulse signal. So that is why it is even more simple, and that is why it deserves 1 mark only. Delta n minus 1 plus delta n plus 1. Okay, to be convoluted with, okay, the H2n, that is the delta n plus delta n minus 1. Okay, this is equal to delta n minus 1 delta n. Now, whether it is delta n or whatever, any signal convoluted with delta n or delta n minus k, okay, will give you x of n minus k. Convolution of a signal with unit impulse will always replicate the signal. Good evening, dreamer. Okay, so delta n minus 1 convolution delta n will be delta n minus 1. N minus 1 with n minus 1, double time shifting, so it will be n minus 2. Okay, time shifting also you can apply. Delta n plus 1 delta n. Okay, delta n plus 1. Last but not the least, delta n plus 1 with delta n minus 1. Okay, plus 1 minus 1 can cancel, that will be delta n eventually. Delta n plus 1, delta n minus 1, it is going to be delta n. Okay, so what is the correct answer? In increasing order, it is going to be delta n minus 2 plus delta n minus 1 plus delta n plus 1. So B is the very correct answer. B is the very correct answer here. Next question, dear. Which of the following statement is or are true? Acha, this question in 2023 actually was a MSQ question, multiple select question. Was actually a multiple select question in 2023 EE 1 mark. If a LTI system is causal, it is stable. No, not every causal system is stable. Okay, if we talk with respect to discrete time only, okay, because all other options are discrete time. Okay, if all the poles of a causal system are inside the unit circle, then it is stable. Okay, depends on the location of poles. Okay, so we cannot say that. Okay, this is not generally true. This is not generally true. Okay. A discrete time LTI system is causal if and only if its response to a step input is 0 for n less than 0. Right. It is causal. Okay. Now, If it is causal, then look into the input applied. Input is applied the unit step input. Unit step input starts from n equal to 0. If the input starts from n equal to 0, for a causal system, output will also start from n equal to 0. Okay, this is definitely correct. So that means the response to step input should be 0 for n less than 0. Yes, it can only start from n equal to 0 onward. So this is true. This is true. A discrete time LTI system has an impulse response Hn of finite duration, then the system is stable. Hn is finite duration. Okay, Hn is finite duration. Will it be stable? See, one of the condition of stability is, let me add up a slide here. One of the condition of stability is, okay, one of the condition for stability is, in terms of time domain, the impulse response should be absolutely summable. The impulse response should be absolutely summable. That is, summation mod Hn should be less than infinity. Okay, now they are only telling that impulse response is of finite duration. But suppose finite duration to have maybe 1, 2, infinity and 3. Maybe one of the value is undefined. Okay, total number of samples are finite, but maybe one of the sample is undefined. Okay, then what is going to happen? Then the system is unstable, na? The summation will be infinity eventually, one of the value is infinity. Next option mein kya bola hai? Okay, so this is also false, dear. This is also false. If the impulse response, okay, modulus of Hn is between 0 to 1. Okay, that means every value is bounded. Okay, then the LTI system is stable. Then the LTI system is stable. Every value is bounded. Okay, it is between 0 to 1. Suppose all the values are 1 by 2. All values are between 0 to 1. Suppose I will take 1 by 2. But the total number of values are infinity. Then also when you take the summation, okay, 1 by 2, 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 keep adding infinite times, it will be infinity only. Now this also will be unstable. So this is also false. Okay, so is or are true. Okay, it was a MSQ question. But what is MSQ question? Multiple select. One or more than one can be correct. One or more than one can be correct. Okay, so no problem. Sometimes in MSQ question only one can be correct. I have told you earlier also many times, and gate 23 में ऐसा question आ चुका है. Okay, ठीक है जी, done है. Next question. Next question. The period of the discrete time signal 2023 EE 2 marks question. It is actually simple for 2 marks level. Okay, the period of the discrete time signal described by the equation below is. Tell me quickly, tell me. Yes, let's do it up, guys. Okay, so what is the period of the discrete time signal? Now, first of all, okay, of course, if there is a periodic signal added with a DC term, okay, it's going to be remaining as periodic with the same period. उसमें कोई effect नहीं होगा. But have a look into this. What is the value of omega here? What is the value of omega here? Suppose omega 1. Okay, that is given by 15 pi by 8. Okay, so what is 2 pi by omega? See, sin omega n or cos omega n, they are only periodic if 2 pi by omega is a rational number. That is the condition for discrete time periodicity. So what is 2 pi by omega 1? 2 pi by 15 by 8. Pi will get cancelled. 8 2s are 16. It is 16 by 15. Yes, it is rational. Ratio of two integers, it is rational. Okay. So the first signal is periodic. But what is the period then? The first signal is periodic. But what is the period? Okay. The period is not 16 by 15 because for a discrete time signal, okay, the period also can only be integer. The period can also only be integer. So what is the period n1? We normally write it as 2 pi by omega 1 multiplied by some constant k. Okay, where k is that minimum integer which will convert the period also to be integer. Okay, so that means it is 16 by 15 into k, right? You will choose what? You will choose the k equal to 15. Okay, because that is the minimum value of k. 15 will cancel and answer will be 16. Okay, so the period n1 is equal to the 16. Okay, similarly guys, let us talk with respect to the second signal separately. What is this? This is the omega 2 which is pi by 3. Okay, what is the 2 pi by omega 2? 2 pi by 3, that is 6. Okay, that is 6. That is directly integer. Of course it is rational, but that is directly integer. Okay, this one is directly integer. Okay, so the period itself will be, the period n2 itself will be 6. Okay, now two discrete time signals are being added having the periods n1 and n2. So what is the final period? Okay, so what is their final period? Okay, so what is the final period? The final period is given by LCM of n1 and 2. It is given by the LCM of 16 and 6. LCM you will calculate, it will be the 48. Correct answer for the question is, the correct answer for the question dear is 48. Okay, the very correct answer for the question is 48. ठीक है, अगर LCM नहीं निकालना तो there is one more method. Okay, there is a one more method. Take the simplest ratio of n1 by n2, that is 16 by 6 है. Simplest ratio के लिए cancel by 2, it becomes 8 by 3. Then the final time period is given by the cross multiplication. 3n1 या 8n2, anyone you can take. Cross multiplication, let me take 3n1 or you can take 8n2 also, any one of them. n1 16 है तो 3 into 16 48. Okay, 48. All right, no issues Rohit. Okay, next question guys, 2023 EE1 mark, decent question, conceptual and property based question. अब इसको कैसे आप short करोगे, that trick you have to identify. How you can make this question as short and sweet. Just a second. How you can make this as short and sweet, वो आपको identify करना पड़ेगा. And think you can. चलो. Okay, what it is for the signals xt and yt shown in the figure, zt is the xt convolution with yt, okay, and that is maximum at t equal to t1. Okay, then t1 in seconds is equal to how much? T1 in the seconds is equal to how much, dear? What is the zt given to you? Okay, what is the zt given to you? It is xt convolution yt. Yt यहाँ पे symmetric दिख रहा है ना मेरे को? Yeah, ठीक है, xt is still symmetric. So what is the formula you can use here? Okay, better convert it as yt convolution xt. Convolution is commutative, you can exchange. Okay, you can exchange. So yt convolution xt, I will write it as y tau xt minus tau d tau. Okay, from minus infinity to infinity. So yt is already given to me. Let me just convert it to the y tau, not a big deal. Okay, let me convert it to y tau. Okay, I'm just changing the name of the variable. But what is xt minus tau? What is xt minus tau? ये समझना पड़ेगा. This is xt given to me, or suppose this is x tau. Let me convert it to tau. What is xt minus tau, dear? What is going to be x minus tau? First of all, this one is symmetric. This one is symmetric, so no effect on folding. X minus tau is what? X minus tau represents the folding. Okay. The x minus tau remains to be same as x tau because it is symmetric function. But what is xt minus tau? So when I draw xt minus tau, actually xt minus tau, and you are plotting with respect to tau, so it is like minus of tau minus t. When you open this bracket, then only you will get plus t. I want x of plus t minus tau. Okay, but when you see with respect to tau, it comes out minus, taking common, it turns out to be tau minus t. What does it mean? It turns out to be tau minus t. That means it is a right shift case. Okay, so what we will do, we will just right shift by how much? Right shift by the t unit. We will just right shift and right shift by the t unit. So that means, okay, if this was 1, it will be t plus 1. The left side was minus 1, it is t minus 1. Okay, both of them are added with the t. Okay, this is what it is. Now, what is zt? It is area under, integration means area. It is the area under product of x tau y. It is the product of y tau xt minus tau. It is the product of these two. I don't want to calculate the complete convolution. See, many places you will find the solution of it, complete convolution, and then you will see where it is maximum. Just try to guess now where it will be maximum. Where it will be maximum. See, this particular rectangle, which is from t minus 1 to t plus 1, this will be sliding, na? Graphical method क्या बोलता है? For if t is negative, if t starts from minus infinity, the rectangle starts from minus infinity, and for when the t increases, it is going to go towards right up to t tending to infinity. Okay. Okay, then you need to multiply this with the y tau and calculate the area. Integration means calculate the area, right? Calculate the area. So, ab dekho dear, when it is going to give the maximum area, suppose it is here, okay, there will be different instances, na? It may be here, it may be here, right? It may be here, okay, even it may be here also. Okay, but here also this will give negative area. See, area being a vector quantity, you have to take care positive, negative. So here, since y tau has negative values, it will give you the negative area. Okay, now there will come a point when you keep sliding it, there will come a point when it completely collides here. Dekho, what is the total duration? Whether it is t minus 1 say t minus 2, t minus 1 say t plus 1, the total duration is 2. Right, very good Harihar, very good. Okay, so now this also is total duration 2. There will come a time, okay, such that t minus 1 collides with 3 and t plus 1 equal to 5. T minus 1 equal to 3. Okay, this will be maximum, okay, for t minus 1 equal to 3, or you can say that the t plus 1 equal to 5. कहीं से भी निकाल लोगे t equal to 4 आएगा. Right, because it is going to completely overlap and it's going to give you the area of this triangle, because iska value to kuch nahi hai, this is having one value. Okay, if the value of x is 1 into y will be y. Okay, so you will get the area of y, you will get the area of this y, okay, which is the area of triangle. Okay, now if you move forward, now what will happen? You will only take some part of the area, means lesser area, means lesser answer. Okay, so maximum answer, maximum area is obtained for this much of the portion. Isse thoda pehle liya, so there may be a negative rectangle area, there may be a positive rectangle area, they can cancel each other. They can cancel each other. ठीक है ना? They can cancel each other. So maximum is obtained for t equal to 4, and they are telling that the maximum is obtained as t equal to t1. Okay, so the t1 value is equal to the 4. It's a good question for 1 mark, and no worries, 2023 EE has anyways been a low scoring paper. 2023 EE was a really good paper and it has been low scoring, topper at 66 marks. Don't worry. Okay, so for 1 mark it is actually a good question considering. Okay, but those who have studied convolution, especially the graphical analysis, then this is very simple. Okay, you know at least the approach, you know, if you have studied the graphical method of convolution. Okay, next question dear. If the input xt and output yt of a system are related as yt is equal to max of 0, xt, then the system is whether linear or time invariant or both. Okay, yt is equal to max of 0, xt. What does it mean? Okay, out of 0 or xt, whichever is maximum, okay, yt will be equal to that. Good evening, Bhanu. So I can say that, dear, there can be two conditions. Now I don't know what the xt is, but there can be the two conditions. Xt may be greater than 0 or xt may be less than 0. If xt is greater than 0, okay, so xt becomes maximum. Okay, so yt will be equal to xt. Yt will be equal to the xt. If xt is less than 0, then 0 becomes maximum. Okay, then 0 becomes maximum and yt will be equal to 0 then. Okay, so yt equal to either xt or 0 based on the nature of xt. Okay, based on what? Based on the nature of the xt. Based on the nature of the xt. Okay. Now whether it is linear or time invariant or what it is. Linearity तो बहुत simply prove हो जाएगी, ठीक है? Now say for example, I take a input x1t which is equal to 3, okay, which is equal to 3. What is y1t then? What is the output? It is max of 0, 3, that is 3, okay. But I take another input x2t, which is minus 2. I take another input x2t which is minus 2. Okay, what is the y2t? It is max of 0, minus 2, and this time maximum will be 0. This time maximum actually will be 0. Okay, okay. Maximum will be 0. Okay, now if I add both the inputs, okay, okay, that is 3 plus minus 2, that will be 1. So what will be the output corresponding to it? Okay, output y will be max of 0, 1, this time it is 1. If two inputs are added, output should also be added. If two inputs are added, output should also be added. So what is the output now? Okay, what is the output now? It is 1. Is it equal to y1 plus y2? 3 plus 0 should be 3. It is not equal to y1 plus y2. It is not equal to y1 plus y2. This clearly proves that the system is non-linear. This clearly proves that the system is non-linear. Clear? System is non-linear. Very soon, Kamal, very soon. Okay, very soon. In my next session, that is Wednesday, I'll probably announce the dates also. Mera next session Wednesday hoga 9 PM ko, I'll announce with the dates also. I'll announce you with the dates also. ठीक है? ठीक है जी, I'll announce you with the dates. Very soon we'll start with the machines by K.N. Rao sir. Yes, Rajesh, we'll plan power electronics also. Okay. Chalo, so this is non-linear. What about time invariance or time variance? Okay, what is the value of, how do we check the time invariance? So dekho, yt can be written in one more manner. Okay, yt is equal to xt when xt greater than 0, otherwise it is 0. I can write down yt is equal to xt multiplied by u of xt. Please check whether it is justified or not. देखो ये justified है कि नहीं. See, whenever xt is greater than 0, it's like ut, t greater than 0, ut will be 1. Na? So when xt greater than 0, unit step will return answer 1. Okay, so xt into 1 will be xt. But if xt is less than 0, okay, if you place less than 0 inside unit step unit step will return 0, xt into 0 will be 0. That's what I want, na? That's what I want. Whenever xt less than 0, I want 0. Whenever xt greater than 0, I want xt only, correct? So that can also be a way to write down yt. Yt is equal to xt into u of xt. Is there any other function of time? No, na? Even if you delayed the input, okay, suppose you take the input as x1t is equal to x of t minus t naught. Okay, what is the output y1t? Okay, y1t will be, the relation is input u of input. Okay, so if I delay the input, my output is, place the x1t, that is x of t minus t naught, u of x of t minus t naught. Okay, now let me directly delay the output. That is the method to check time invariance, na? That is the method to check time invariance. Okay, first calculate the output due to delayed input. Now produce the same delay in the output directly. A time shift in the input should produce a similar time shift in the output. So if I place the similar time shift in the output and then calculate output, it should match with this expression. So check kar lete hain. So yt, wherever t is there, replace t minus t naught. Wherever t is there, replace t minus t naught. So x of t minus t naught, u of x of t minus t naught. Okay, now very clearly, y1 equal to y2 and the system is time invariant. The system is time invariant. Okay, so it is non-linear but time invariant. Very correct answer, Hari. It is non-linear but time invariant. Good going. It's a correct answer, Hari, B. Okay, it is non-linear but at the same time it is time invariant. Done hai ji? Okay guys, let's move ahead to the next question. Okay, consider the system as shown below, where yt is equal to x of e power t. Okay, it is x of e power t. Then the system is what? Linear, causal, non-linear, causal, etc. 2022 EE2 marks question. Okay, x of e power t. भाई causality तो बहुत simply prove हो जाएगी. If you put t equal to 0, what is y0? X of e power 0, that is x of 1. You want to calculate the value of the output, okay, at t equal to 0, that is the present time. But what is the value of the input you require? You require the value of the input at t equal to 1, which is the future time. Which is what? Which is the future time. Okay. So that means the system is non-causal. Okay, whenever you need the future values of the input, system is non-causal. Okay, non-causal to hoga linearity. It is x of e power t. Dear, yt is given to you as x of e raised to the power t. Okay, suppose you take the first input x1t corresponding to a input x1t. Suppose the output, what is the output? It is x1 e power t. Okay, corresponding to another input x2t, output is x2 e power t. But now if I take a input xt is equal to x1t plus x2t, okay, what is going to be the output? What is going to be the output corresponding to the input xt? Output is x of e power t. Okay, now everywhere t, please replace by e power t. If you know xt, what is x of e power t? It will be x1 e power t. Simple maths apply कर रहे हैं, plus x2 e power t. Okay, what is x1 e power t? Is y1. What is x2 e power t? Is y2. Okay, that means the output that you have got is equal to y1 plus y2. It follows additivity. Similarly, it will follow scaling also. Okay, additivity follow किया तो scaling भी कर ही लेगा. It is the linear case. It is the linear case. It follows additivity. Okay, it is the linear case. Clear? It follows what? It follows the linear case. Very simple, na? If you multiply 2 here, okay, the output will also be multiplied by 2. Very logical. Okay, very logical. If the input is 2x, output will also be, 2y. Okay, so it is linear. So it is linear but non-causal. Option number C. It is linear but non-causal. Please pay attention. Please pay attention if the relation was of this form. Okay, e raised to the power xt. This is non-linear. Difference है यहाँ पे. The relation between input and output here is linear. Okay, input further depends on an exponential function of time. That is a different case. Okay, but relation between y and x, it is simply linear. Y is x power 1 dependency. But if you write down y equal to e power x and you apply the similar method, it is non-linear. We know that it is non-linear. So understand the difference. Okay, if I write down yt is equal to exponential e power xt, then it is non-linear. Yt is x of any function of time, but ultimately y depends on x directly. It is linear. Okay, so it is linear but non-causal. It is linear but non-causal. Okay. Next question. Sometimes they ask very simple, unbelievably 2 marks. Okay, actually 2022 was a very simple paper for electrical if I see that also. Let a causal LTI system be governed by the following differential equation. Yt plus 1 by 4 dy by dt is equal to 2xt. Converting it into the S domain. Converting it into the Laplace domain. Okay, Yt has the Laplace transform Ys. 1 by 4 dy by dt has the Laplace transform Sys is equal to 2xt. Okay, so now what is the transfer function? Okay, what is the transfer function? What is the transfer function? Okay, I need the impulse response. Suppose first let me calculate the transfer function, which is nothing but the ratio of ys divided by xs. Okay, ratio of input to output Laplace transform. Okay, so x divide on the left side, right side mein bacha 2, and from here you are sending 1 plus s by 4, or finally if you simplify this, multiply by 4, so it becomes 8 and then s plus 4. 8 upon s plus 4, 8 upon s plus a. Whose Laplace transform? Very fundamental it is. Whose Laplace transform is this? Okay, now the inverse Laplace transform will be the impulse response. Okay, what is the impulse response? 8. 1 upon s plus a, e power minus 80 ut. So e power minus 40 ut. E power minus 40 ut. 8 e power minus 40 ut. It is D. One of the very simplest type of question that can be asked. One of the most simplest type of question that can be asked. Can I say that ना? इससे ज़्यादा simple तो क्या ही पूछेंगे? Right? चलो, done है. Next question. Next, 2023 1 mark. Current year 2023 1 mark. Again a very simple category. Again I take the Laplace transform and they are asking the impulse response. So dy by dt Laplace transform Sys plus 3yt Laplace transform 3ys is equal to the 2xs. Okay, so what is the ratio of ys upon xs? Okay, right side mein bacha 2. From the here you will take s plus 3 on the right side. Okay, so what is the impulse response? 2 upon s plus 3. So 2 hata de. 1 upon s plus a, e power minus 80 ut. So e power minus 3t ut into 2. Okay, option number C. Okay, option number C. So these two were like very simple. 2022 also, that was 2 marks. This time it is 1 mark. But very similar. Intent is very, very similar. Okay, just numbers are changed. Next question. 2021 doubly 2 marks. Again a simple question with Z transform. Mostly formula based. Okay, mostly formula based. The causal signal with the Z transform, okay, is what? Okay, suppose the Z transform xz is z square z minus a power minus 2, or you can write down this Z transform as z square divided by z minus a whole square. Okay, better you can separate this as, okay, one of the very commonly known signals can be used here. Okay, some standard signals Z transform you should know, like you should always remember a power n un has the Z transform Z upon Z minus a in the positive powers. Okay, for mod Z greater than mod a. चलो ROC यहाँ पे नहीं जा रहे, causality बोला हुआ है ना. For n a power n un, for n a power n un, it is derived by minus Z d by dz of xz. Okay, and after solving it, you get az upon z minus a whole square, az upon z minus a whole square, and actually n a power n un, okay, that is also a standard signal. You should remember the Z transform. Okay, az upon z minus a whole square. तो देखो z minus a whole square तो है यहाँ पे. Okay, there is z also, z square है, तो we will split that z. Okay, we will split the z and let us write this as z upon z minus a whole square, but there is no a here. Okay, so multiply by a. If you are multiplying by a, also divide by a. So I have broken it now. 1 upon a, az upon z minus a whole square into the z. So what should be the xn? What should be the xn? Okay, see, if it was only this particular term, az upon z minus a whole square, then it is given by n a power n un, but it is multiplied by z. But it is multiplied by z. Time shifting property. It is multiplied by z. What is the time shifting property? If xn has the z transform xz, okay, x of n plus 1 will have the z transform zxz. Okay, yeah, in general, x of n plus k will have the z transform z power plus k xz. If it is x of n minus k, the z power minus k. Basic time shift property. Basic time shift property. So here it is z power 1 multiplied to n plus 1. N plus 1, a raised to the power n plus 1, u of n plus 1. Correct. Now a power n plus 1, so a power n into a power 1. A power 1 cancel hoga. Final answer is n plus 1. Then you have a power n. Then you have u of n plus 1. N plus 1, a power n, u of n plus 1. Option B, clearly. Okay. Correct answer, Bhanu. Option number B. Simple enough. Okay. Option number B it is. Correct hai? Chalo. Moving ahead to the next question then. The Z transform of a discrete signal xn is xz. Okay, 4z upon z minus 1 by 5, z minus 2 by 3, z minus 3 with the ROC equal to R. Which of the following statement is true? Which of the following statement is true? The discrete time Fourier transform converges if what? Bhai, simple. Remember, recall one point. Ki when does the DTFT converge? DTFT converges if the ROC contains unit circle. Which of the ROC contains the unit circle? ये देख लेना and please tell me which of the answer is right or true or false. है ना? Just okay. Yeah, let's complete that. Let's complete. All right, Hari, Har and Gajendra say the answer is B. Let's check it out. Let's check that out. Okay, so if the ROC contains what? If the ROC contains the unit circle. ये check करना है. So what are the poles here? Okay, if you notice the poles, what are the poles here? in sequence 1 by 5, then greater 2 by 3, and then greater will be 3. These are the poles. Okay, so if ROC, of course, if you talk with respect to poles, okay, if you talk with respect to poles, there is the pole 1 by 5, then 2 by 3, and then suppose this is 3. Okay, so where is the unit circle? Unit circle is definitely, okay, here between 2 by 3 and 1. Okay, between 2 by 3 and 1. So to include the unit circle, the only possibility is, okay, okay, take the circle passing through 2 by 3 and take the circle passing through the 3, and ROC should be between them. Then only the unit circle is included. Okay, so it should be between 2 by 3 set 3. Okay, it should be between the 2 by 3 set 3. Okay, mod z greater than 3 is also ROC, but that will not be defining the DTFT. Unit circle has to be included. B is the correct answer. The DTFT of the xn converges if R is such that xn is a left-sided sequence. No, for left-sided sequence, what should be the ROC? For left-sided sequence, what should be the ROC? Okay, left-sided means interior circle. Okay, for left-sided, you know what should be the ROC? It should be inside the interior, it should be inside the innermost pole. Innermost pole is 1 by 5. Then you will write down that the ROC is mod z less than 1 by 5. Okay, now option number D bolta hai DTFT converges if R is such that xn is a right-sided sequence. Right-sided sequence will always have an exterior, ROC, and exterior to what? Exterior to the outermost pole always. Okay, because you cannot include poles na. Okay, so then the ROC becomes the mod z greater than 3. Okay, which is similar to option number A. Okay, so the only correct answer is option number B as already specified. Okay, done. Next question then. Next question, 2021 2 marks Fourier transform question. Okay, consider a continuous time signal xt defined by xt equal to 0 for mod t greater than 1 and xt equal to 1 minus mod t for mod t less than equal to 1. Let the Fourier transform of xt be defined as x omega. We know the regular definition, integral xt e power minus j omega t dt. What is the maximum magnitude of x omega? What is the maximum magnitude of x omega? Have we identified what is this signal? It is just given in words. What is this signal actually? If you identify this, your problem is half solved. Okay. So if I want to consider xt here, okay, for mod t greater than 1, it is definitely 0. Okay. For mod t less than 1 means t is between minus 1 to 1. Correct, Harihar? Correct. T is between minus 1 to 1 and xt is equal to 1 minus mod t. So if t is positive, 1 minus t, negative slope, decreasing line. If t is negative, 1 minus 1 plus t, okay, positive slope. Okay, this is actually the line. Let me write down, this is actually the line 1 minus t, this is actually the line 1 plus t, because it has positive slope, increasing line, and this has a negative slope. The signal that is given to you, you should be able to highlight that it is a triangular definition given to you. It is a triangular definition that is given to you. So what is the xt actually? It is a triangular signal, tri of t by 1. It exists from minus 1 to 1. If the triangle exists from minus t se t, we call it as tri t by t. We call it as tri t by 1 here, or simply tri t. Now what is the Fourier transform? Standard formula. If you are going to derive it, you are going to end up in wasting a lot of time. Okay, these are all standard results. Okay, rectangle, triangle. Okay, you must remember. So what is the Fourier transform for tri t by t? It is given by t sampling square omega t by 2. It is given by the t sampling square omega t by 2. So what is the Fourier transform for tri t? If I put t equal to 1, I get the Fourier transform sampling square omega by 2. Sampling square omega by 2. Sampling square omega by 2. What is the maximum magnitude of x omega? Okay. What is the maximum value of x omega? X omega is sampling square omega by 2, and we know that sampling square waveform will take the maximum, okay, at the theta equal to 0, at the omega equal to 0 actually. Okay, it will be attaining the maximum at the omega equal to 0 only. Okay, the maximum value is at omega equal to 0, which is given by 1. Which is given by 1. So its maximum possible value is 1. Sampling theta and as well as sampling square theta, they have the maximum value equal to 1. Okay. Magnitude represents area or not means, can you please can you please elaborate your doubt, Harihar? You want to talk about x0. Okay, the maximum magnitude of x omega, here it is at 0. Okay, here it is representing area, correct? Okay, but not in general, na? Not in general. The area of a signal xt, if you want to relate by this, the area of a signal xt is equal to the value of the Fourier transform at omega equal to 0. In this case, Harihar, okay, in this case, Harihar, the maximum magnitude of x omega is at omega equal to 0, but it may not be always true, correct? It may not be the always true. Okay. Okay. So here it is true. For the triangular waveform, it is true. Okay. Even if it is t sampling omega square by 2, the maximum value will be t. Maximum value will be t. That is agreed. Okay. That is agreed. Okay. Done. Next question. 23E1 mark again. The Fourier transform x omega of the signal xt is given to you. X omega equal to 1 for mod omega less than omega naught. It is 0 for mod omega greater than omega naught. It is this time the Fourier transform given, which is going to be a rectangular pulse. It is this time a Fourier transform given, which is going to be a rectangular pulse, because what is the x omega? What is this x omega? यहाँ बना देते हैं. Okay. What is this x omega? Now, for modulus of omega less than omega naught, that means any value between the minus omega naught up to the plus omega naught, between the minus omega naught up to the plus omega naught, x of omega is going to be 1. X of omega is what? It is going to be the 1. This clearly shows a rectangular waveform. Okay, this clearly shows that x omega is a rectangular waveform. Rect of omega by how much? Okay, rect of, in rect we write down the duration, and the total duration is minus omega naught to omega naught. The total duration is 2 omega naught. So we have rect of omega divided by 2 omega naught, correct? We have the rect of omega divided by the 2 omega naught. Rect of omega divided by 2 omega naught. Okay, that is the value of x omega. Okay, now whose Fourier transform is rect? Rect Fourier transform is sampling, sampling Fourier transform is rect as per the duality. Okay, remember both the formula like we revised for triangular. Rect Fourier transform is rect t by t, t sampling omega t by 2. Okay, and by duality, sampling Fourier transform is, suppose we write it in the form of sampling at. Sampling at Fourier transform is pi by a, rect of omega by 2a. Please remember, very, very important Fourier transform pairs. Very important, very crucial Fourier transform pairs. Okay. So here, the x omega is a rectangular, the Fourier transform is a rectangular information. So time domain signal is going to be sampling. Okay. Time domain signal is going to be what? Sampling. Okay. Kya given hai x omega aapko? X omega here, what we have is rect of omega by 2 omega naught. Omega by 2 omega naught. So what should be the xt? What should be the xt? Omega by 2 omega naught. Place a equal to omega naught, and this constant term is not there, shift on the left side. Okay, that is a. A ki jagah rakha omega naught. A is equal to omega naught divided by pi into sampling at, that is sampling omega naught t. That is the xt given to you. That is the xt given to you. Okay. Okay. So what it is? Now xt ka information aa gaya hai. Xt tends to be an impulse as omega naught tends to infinity. Very correct. Okay. Very correct. Okay, let me take another slide here. First, let me write down what is the xt. It has been obtained as omega naught divided by pi sampling omega naught t. Sampling omega naught t. Okay, so again let me sketch the sampling curve here. Okay, at omega equal to 0 it takes the maximum value. Sampling maximum value is 1 multiplied by omega naught by pi. Okay, and then these are the null points. How do you find out the null points? इस पे भी क्वेश्चन पूछा जा चुका है पहले. Null points when omega naught t is equal to n pi, where n can be 1 plus minus 1, both side में होगा plus minus 1 plus minus 2 etc. Okay, so what is the t? Then it is given by sampling omega naught p में t is given by n pi divided by omega naught. Okay, okay, so n का first value लिया, this is omega naught by pi. Okay, this is 2 omega naught by pi and etc. On the left side this is minus omega naught by pi. Now what happens? What they are trying to tell here? Okay, whether the sample filter of signal system is there. See, no separate filters, it has been removed from the GATE syllabus, Aryadeep, but basic filter classification. Okay, that is basic expected from electrical or electronic students. Okay, given the Z transform, you're given the DTFT, can you tell whether it is high pass, low pass, band stop? Okay, so what is the low frequency, what is the high frequency to do put, wo sab aana chahiye, but not the special type of filters. It's at least in the GATE. Okay, it is not there. But basic filter knowledge, basic frequency knowledge should be there. Okay, first option says that 2023 EE1 mark, good question again. Xt tends to be an impulse as omega naught tends to infinity. As omega naught tends to infinity. Okay, x naught decreases as omega naught increases. X0 decreases as omega naught decreases. Now, xt tends to be impulse as omega naught tends to infinity. Correct? Okay, as omega naught, oh sorry, isko main ulta likh diya. I've written it reverse actually. So what was this? Pi by omega naught. First value pi by omega naught. Okay, then 2 pi by omega naught and etc. Similarly, left side minus pi by omega naught. So see, as omega naught tends to infinity, what is going to happen? To this curve, if you place omega naught tending to infinity, this is one more way of deriving the impulse signal. Understand here, very good concept. Okay, all these points, 1 upon infinity, they will converge to 0. But what about the height of the signal? What about the maximum value? Omega naught tending to infinity, so that maximum value will also tend to infinity, and you are going to get the appearance of, you are clearly going to get the appearance of a unit impulse signal, because all of these points converge at origin, all of them converge to the single point, okay, at 0, and the value at 0, okay, tends to infinity, and that is how we represent a continuous time impulse signal. Upgoing arrow, the value going to infinity, but its area is 1. Okay, but its area is 1. Okay, it represents impulse. Correct. It represents definitely an impulse. Okay. Correct. Area we might have to calculate, but that's okay. It is at least an impulse. Chalo. Next, so A option itself is correct. It is a true statement. X naught, see, ये साफ दिख जाएगा. X naught decreases at omega naught increases. No, na. X0. Okay, this is the xt. Okay, this is the time domain signal xt. Okay. As omega naught increases, x0, the value at 0 is also increasing only, na. So B is definitely opposite. At t equal to pi by 2 omega naught, xt is minus 1 by pi. You can check it out here. Pi by 2 omega naught. Pi by 2 omega naught. Place here. Okay. Pi by 2 omega naught, pi by 2 omega naught cancelled, pi by 2, okay, sampling pi by 2, okay, sin pi by 2 upon pi by 2, the sin pi by 2, 1, okay, divided by pi by 2, okay, no, it is not going to be matching. वैसे भी एक match हो गया तो need not check others, but still if you put and write down sampling as sin theta by theta, C and D will also not come up, okay, 1 by pi या minus 1 by pi ऐसा कुछ नहीं आ रहा है, ठीक है, चलो, done है, this is also done, a decent question I can say. Okay, that is why 2023 was a good paper for EE, because even for 1 marks some questions were simple also, but for 1 mark also some questions are taking little bit understanding. How I write xt from this formula? Sampling 80 Banu has the Fourier transform pi by a rect omega by 2a. Now the Fourier transform is rect of omega by 2 omega naught. Okay, so what should be the time domain signal? Sampling omega naught t. Okay, acha, sampling omega naught t में pi by a भी आना चाहिए, but that is a constant ना. If it is not on the right side, shift it to the left, a upon pi. Okay, तो a upon pi, where a is equal to omega naught actually. ठीक है? From this basic formula I have written, and both of these formulas very important. You must remember. They are related by duality property, but you should directly remember. Rect Fourier transform is sampling. Sampling Fourier transform is rect. Similarly, like previous question, triangular Fourier transform is sampling square. Sampling square Fourier transform is triangular pulse. Done hai ji? Next question. Let ft be an even function, that is f minus t equal to ft for all t. Okay, let the Fourier transform of ft be given as, okay, we know the Fourier transform formula, integral ft per minus j omega t dt. Suppose df upon d omega is minus omega f omega for all omega and f not equal to 1, then what should be this answer? Okay, df, okay, we'll start from here only. The Fourier transform is given in the differential equation form. df by d omega is minus omega f omega, correct? It is minus omega f omega given to me. Minus omega f omega. So let me try to solve it up. df omega divided by f omega is minus omega d omega, integrating both the sides, df upon f ln f omega is equal to minus omega, omega integral omega square by 2 plus constant. Omega square by 2 plus constant. So what is the value of f omega? E raised to the power minus omega square by 2 plus c, या इसको split कर देंगे e power minus omega square by 2 into e power c. Okay, e power c को एक constant ही बोल दीजिए ना. E power c is a constant, suppose that is some constant k. So what is the Fourier transform? It is k e raised to the power minus omega square by 2. K e raised to the power minus omega square by 2. Acha, also given f0 equal to 1. You are given na f0 equal to 1. So 1 is equal to k e power 0. E power 0 1 है तो k का value 1 है. E power 0 is equal to 1. So the value of k equal to 1. So the value of k equal to 1. So what is the f omega? What is the f omega? E raised to the power minus omega square by 2. Okay. Then what should be f0? What should be the f0? Tell me. E power minus omega square by 2 hai. This is e power minus omega square by 2. Okay, whose Fourier transform is e power minus omega square by 2? Whose Fourier transform is e power minus omega square by 2? E power minus at square. Gaussian ka Fourier transform is Gaussian. Has the Fourier transform has the Fourier transform root over pi by a e power minus omega square by 4a. But I have omega square by 2. यहाँ पे 4a है तो एक substitution है. Put down a equal to half. Put down a equal to half. So you get e power minus t square by 2 having the Fourier transform pi divided by half. Okay, e power minus omega square by 4a. 4a का value 2 हो गया. So pi upon half is 2 pi. Bring it on the left side. 1 upon root 2 pi. E power minus t square by 2 has the Fourier transform e power minus omega square by 2. That's it. So what is the value of the ft? F omega तो निकाल ही लिया था. Now I have the ft also. ft is 1 upon root 2 pi e raised to the power minus t square by 2. Correct है ना? E power minus t square by 2. So what is the value of f0? आ गया. E power 0 will be 1. Answer is 1 upon root 2 pi. Okay, root 2 pi greater than 1 होगा. Definitely 2 pi is 6.28. Under it will be definitely greater than 1. Okay, so answer will be less than 1. Denominator greater than 1. So overall answer less than 1. So f not less than 1. Option number A should match. 2021 double E. ठीक है, good question. Hi trail mail. ठीक है जी, done है. Okay, so option number A, f not less than 1 is the correct answer. Okay, yeah. So guys, before I move ahead, let me also keep you updated that, okay, if you want to involve in more practice, like, okay, you are regularly practicing on YouTube, but on the BYJU'S exam prep app also, you will find several practice sessions, live also, recorded also, and there will be so many practice quizzes also available. Daily at any time, you can follow one quiz at least. Okay, of any topic of your interest. Keep participating in quizzes. Keep competing with your fellow aspirants and see where do you stand. Okay, see where do you stand in the GATE preparation. Okay, so for more practice, and even there are study notes and lots of articles available helpful for your GATE preparation, you can download the BYJU'S exam prep available on the Google Play Store, or there is a link in the description. You can directly download using the link. Okay, next question, 2022 EE 2 marks question. Here it is. Let an input xt is 2 sine 10 pi t plus 5 cos 15 pi t plus 7 plus some 7 sine 42 pi t plus 4 cos 45 pi t is passed through a LTI system having the impulse response. Sinusoidal input is given. What will be the output? Okay, what will be the output? So just let us sketch. Okay, let us sketch. Roman, which last step? What is the problem here? The last step is just calculating f naught, na? It's just calculating f naught. I have substituted t equal to 0, so e power 0 becomes 1. So answer is just 1 by root 2 pi. Okay. Hanji dear. So because I want the output to a sinusoid input, let us calculate the frequency response. Okay, and it is, what is this ht? What is this ht? It is 2 sine 10 pi t by pi t. So let us try to convert into sampling function. To convert into sampling, let me divide by 10 and also multiply by 10. Okay, so 2 into 10, and then this will become sine 10 pi t divide by 10 pi t, okay, into cosine of 40 pi t. Okay, now this is equal to 20 sine theta by theta is sampling function, sampling 10 pi t into cos 40 pi t. Modulation property will also apply here. Okay, first I should sketch the Fourier transform for sampling 10 pi t. What should be the Fourier transform for sampling 10 pi t? Yeah, 20 sampling 10 pi t. 20 sampling 10 pi t. Just now we revised the formula, na? Okay, just now we revised the formula. 20 को अलग कर देंगे. Sampling 80 having the Fourier transform pi by a. ये a हो गया pi by a rect of omega by 2a. Omega by 2a. So 2a will become 20 pi. Clear? So what should be the Fourier transform? Pi cancel. This is twice rect of omega by 20 pi. Okay. Now dear, suppose this much part is known as xt. चलो xt तो input है, इसको xt नहीं बोलते. Suppose this much part is known as gt. Okay, so this is its Fourier transform g omega. Now what is the ht actually? What is the actual impulse response of the system? Okay, that is given by, okay, this part which I have called it as gt. इसको gt बोल दिया. Okay, तो gt multiplied by cos 40 pi t. gt is multiplied by cos 40 pi t. So here modulation will apply. Modulation property will apply. And as per the modulation property, if any signal is multiplied by a cos omega naught t, if a signal is multiplied by cos omega naught t, then its spectrum is shifted to higher frequencies. Centered at plus minus omega naught. So its spectrum will be h of omega will be equal to g of omega plus omega naught. Okay, this is the omega naught actually. Okay, the frequency of the cosine signal, that is 40 pi. G of omega plus omega naught plus g omega minus omega naught and whole divide by 2, amplitude divide by 2. Okay, so everybody knows what is the sketch of rect. Okay, everybody knows what is the sketch of rect. इसको यहाँ पे बना देते हैं रफ में. Okay, rect of omega by 20 pi. 20 pi means the duration. 20 pi means the duration. That is from minus 10 pi से plus 10 pi. Then it will be 20 pi. And the amplitude is how much? Amplitude is true. Okay, that is what? The g omega. Now I want g omega plus omega naught, g omega minus omega naught. One right shifted, one left shifted. Okay. Centered at omega naught. What is omega naught? 40 pi. And amplitude whole divide by 2. So what is the amplitude there? 2 by 2, 1. Okay, so the final Fourier transform, the final frequency response of the system. With respect to omega, I am going to plot h of omega. I am going to plot the h of omega, and that is given by इसको 40 pi से shift किया. It is going to be centered at the 40 pi. This one will be centered at 40 pi, and the width is minus 10 to 10. So if you take minus 10 here, that's 30 pi. Plus 10 on the right side, that will be 50 pi. Okay. At the same time, okay, left shifted version. Achha, how much is the amplitude? This is going to be 1. How it is 1? 2 divided by 2. Okay. On the left side, there has to be identical rect. Okay, centered at minus 40 pi, 10 to the left, 10 to the right. So this is minus 30 pi, this one is minus 50 pi, and this answer is equal to the 1. This answer is equal to the 1. That's it. Okay, now given the input, what are the frequencies in the input? 10 pi, 15 pi, 42 pi, 45 pi. Only which of the frequencies will pass? At 10 pi and 15 pi. Okay, input contains, I'm not writing the exact input, but input xt contains what are frequencies? एक बार renote करेंगे. 10 pi, 15 pi. It contains 10 pi, it contains 15 pi, it contains 42 pi, it contains 45 pi, but 10 pi and 15 pi, the gain of the system is 0. Okay, 10 pi and 15 pi, dear, the gain of the system is 0. So these two will be blocked. Okay, these two will be what? Blocked. And the output will contain what? Output should contain 42 pi, 45 pi. Okay, 42 and, sorry, यहाँ पे 42, 45, both are within this range. Okay, so output should be that which is containing 42 to 45. Acha, the gain of the output will be same because the gain of the input, the system is 1. So 1 into anything, 1 into x will be x. Okay, so 7 sine 42 pi t, 4 cos 45. As it is will repeat because the gain is 1. So 7 into 1 will be 1, 4 into 1 will be 4. The correct answer is option number C. Correct answer is option number C, dear, in that case. Okay, good question. Good question. 2022 doubly 2 marks. Good question. Okay, it's all the fundamentals, not difficult, but I'll call this category as a good question. Okay, I'm telling you repeatedly, the Fourier transform of sampling function, it's just very important actually. Okay, if you only sketch, okay, the frequency response of the sampling domain time function, it is a low pass filter. If you only want to talk about g omega, what is this g omega? Okay, it is the frequency response of an ideal low pass filter. Only modulation has been applied. Okay, so that shifted to the right and to the left. Okay, to the higher frequencies. Next question, 2023 2 marks question based on sampling. 2023 2 marks question. A signal xt is equal to 2 cos 180 pi t cos 60 pi t is sampled at 200 Hz and then passed through an ideal low pass filter having the cutoff frequency of 100 Hz. The maximum frequency in the filtered signal will be how much? Sampling pe hai. Okay, it is on the sampling. A signal 2 cos 180 pi t cos 60 pi t. First of all, what is 2 cos A cos B? Directly apply karte na. What is 2 cos A cos B? xt is 2 cos A cos B. Okay, and that is given by what? That is given by cos A plus B. Okay, that will become 240 pi t plus cos A minus B, a basic trigonometric identity, and when you subtract you will get 120. Cos A plus B plus cos A minus B, dear. Okay, okay, 240 pi t and 120 pi t, cos A plus B plus cos A minus B. Okay, yes, trail mail, right now I am taking it in the crash course. Okay, in the premier batch I am taking currently in the crash course. It is already running live daily at 3 p.m. daily at the 3 p.m. Okay, so this is what it is. Okay, cos A plus B plus cos A minus B, and now it is going to be sampled at 200 Hz. Now we know what happens after sampling. Pehle iska Fourier spectrum bana le. Okay, what is the Fourier, what is the Fourier transform of a sinusoidal signal? Suppose cos omega naught t, it contains only the impulses at plus omega naught and minus omega naught. Okay, so if you only want to draw what is going to be x omega, okay, it contains impulses at plus minus omega naught. What is the omega naught here? What is the omega naught here? Yeah, there are 2 omega naughts here. Okay, this is 240 pi. Achha, actually better let us sketch in terms of f because the output frequencies are demanded in terms of f. Okay, so this is 240 pi, divide by 2 pi kya, to 120, and this is 120 by 2 pi, that is going to be 60. So 60 and 120. Okay, these are the two frequencies present here, 60 and 120. Let's say this is the 60, Let's say this is the 120. Okay, so there will also be at -60 and at -120. Okay, but this is only XF. Now this is sampled at 200 Hertz and then passed through ideal low pass filter. So what is the sampled waveform? What is the Fourier transform of the sampled signal? Sampling study किया है तो ये directly आपको sketch करना आना चाहिए. What is the Fourier transform of the sampled signal? What is the Fourier transform of the sampled signal? Okay, where the sampling frequency is 200 Hertz. The sampling frequency is 200 Hertz. It is sampled at 200 Hertz. Okay, so we know that it is XF plus X of F minus 200, X of F minus 400 and similarly left shifted also. तो ये तो रहेगा. This will still be there, dear. This is still going to be there. इसको तो replicate करना ही पड़ेगा. This is still going to be there. This is the XF that is anyways going to be there. Okay, but now X of F minus 200. Let's do the right shifting. Okay, so this is going to be centered at 200. So 200 minus 120, 80 भी आ जाएगा यहाँ पे. Okay, 80 also will come up here. Okay, 200 minus 60. Okay, that is 140 will also be there. थोड़ा सा आगे चले तो 120 भी आ गया. Okay, then 200 plus 60. Then it is going to be 260. Okay, and then it is going to be 200 plus 120, that is 320. Okay. Similarly, again shifted by 400 also. And even left side also it will be there. Okay, even the left side also will be there. Okay, minus 200 plus 120, minus 80 bhi aayega. Similarly, minus 140. Similarly, the minus 260. Similarly, the minus 320. Okay, let me write down these values. This is 60, this is 80, this is 120, 140, 260, 320. Okay, so this is symmetrically minus 60. चलो ये लिखने का need नहीं है. They are all symmetric value. Now this is passed through an ideal low pass filter having the cutoff frequency of 100. Okay, now you are going to pass it through an ideal low pass filter having the cutoff frequency of 100. ये रहा 100. Okay, the cutoff frequency is 100. Okay, after doing this, what is the maximum frequency present in the filtered signal? What is the maximum frequency present in the filtered signal? The maximum frequency present in the filtered signal is 80. Filtering के बाद आपको मिलेगा 60 and 80. The maximum frequency present will be 80. Will be what? Will be equal to the 80. Clear, everybody? That will be the 80 Hertz. Good question again. Okay, but sampling पढ़ा है तो हो जाएगा. Correct answer, हरिहर. Okay. You can directly find that now on the app Trailmail. You can directly search within the Premier batch only about the crash course and all. You will have the access to that as well. Don't worry. For maths and all, you can search to the score booster course. Everything access you will automatically have Trailmail. ठीक है जी? So if you know sampling, then you're able to solve the question. You should know what is the Fourier spectrum of the given signal which is sampled. Then what is the Fourier spectrum of the sampled signal? We know that if you know x omega xf, then after sampling, it is going to be right shifted by 200, 400 and also left shifted by 200, 400, etc. It will be repeated. It will be repeated. So this one, I have taken x omega, then shifted by 200. Okay, all these four shifted by 200. Similarly shifted by minus 200 on the left also, and etc. And then I've put a low pass filter whose cutoff frequency is 100. Okay. So these are the, so now they have asked the maximum frequency. Sometimes in the question they're asking, tell us what are the frequencies present. So it will be 60 and 80. Not only maximum, sometimes they tell what are all the frequencies present at the output of the ideal low pass filter. Okay. Chalo. Done hai ji. Next question chalte. If this is done, let's go to the next question then. This was also a decent question. Okay, double 2 marks, 2022, good question again. Okay, the discrete time Fourier series representation of a signal. Now many double students believe कि यार DTFS and DTFT उनको नहीं आएगा, syllabus में है या नहीं. See, 2022 there is a question, 2023 also I will show you there is a question. Okay, so guys, let me tell you, actually for electrical students, discrete part actually is more important these days. Z transform is important. Okay, discrete time convolution is important. DTFT is important. Okay, DTFS is important. It is important for double E. Acha. Continuous part se what is most important thing for double E? It is the Fourier transform, CTFT. वहाँ से question जरूर आता है. Have a look into this. The DTFS of a signal with period n is given by, we know what should be DTFS. Summation 0 से n minus 1 a k e power j k omega naught n. Okay, e power j k omega naught n. Omega naught को वो 2 pi by n, यहाँ पे कुछ typo error हो गया है. Okay, this should be of the form summation a k e raised to the power j, okay, e power j k 2 pi by n into n. Okay, there's some typo error, I think. There's some typo error here. Okay, from summation 0 से summation k equal to 0 से n minus 1, that is okay. Okay, now a discrete time periodic signal with the period n equal to 3 has the non-zero Fourier series coefficients a minus 3 and a4 given to you. What is the value of the signal? Okay, period n is equal to, okay, period n is equal to 3. Now guys, remember DTFS Fourier series coefficients. Okay, the discrete time Fourier series coefficients, which we call it as AK, they are always periodic. They are always periodic. Okay, with how much period? They are always periodic with the period equal to n. Okay, that means whatever is AK will be AK plus n. अब देखो आपको क्या क्या given है. You are given a minus 3 and you are given a4. You are given a minus 3 and you are given a4. a minus 3 का value 2 है and a4 का value 1 है. Okay, but whatever is a minus 3, okay, a minus 3 plus 3, okay, that means a naught will also be 2. Okay, whatever is a4, okay, अच्छा, तो a4 can be written as a1 plus 4, okay, a1 plus 4, that means a1, okay, a1, sorry, a1 plus 4 क्यों बोल रहा हूँ, a1 plus 3, periodic with period 3 ना. Okay, so a1 and a1 plus 3 are same. Okay, so a4 should be equal to a1, that is equal to 1. Okay. Okay, right. So these are the only non-zero Fourier series coefficients. Rest all are 0. Rest all are 0. So normally we should write down, okay, normally we write down the Fourier series coefficients from 0 to n minus 1. From 0 to n minus 1. So what is a0? What is a0? ये आ गया है 2. Okay, what is a1? It is 1. Rest all 0. Rest all 0. This is in the range 0 से n minus 1. So what is the signal xn now? The Fourier series formula is summation k is equal to 0 से n minus 1. n का value 3 रख देते हैं. a k e raised to the power j k 2 pi by 3 into n. Okay. So if I start expanding for k equal to 0, from k equal to 0, 1 and 2, k equal to 0 रखा डियर, कितना होगा? k equal to 0, a naught का value 2 है. Okay, a naught का value 2 है. Okay, but then it will be e power 0. Okay, then a1. What is the value of a1? 1. 1 into e raised to the power j, k का value 1 रखा, तो 2 pi by 3n. Okay, that's it. Okay, plus 0. The next value a2 is 0. Summation 0 से 2. That's what I want to write. Summation 0 से 2. Okay, so what is the xn? xn is simply 2 plus e raised to the power j 2 pi by 3 into n. 2 plus j e power j 2 pi by 3 into n. Okay, 2 plus, acha, now, okay, we have two options with 2 plus, but they are not matching up. Okay, e power, first of all, 2 pi by 6 kaise aaya, and this multiplied by cosine. So some calculation manipulation they are expecting. Some basic calculation manipulation they are expecting, वो भी कर लेंगे यहाँ पे. Okay, so here you have 2 pi by 3 and options are suggesting कि 2 pi by 6 में जाना है. 2 pi by 6 में जाना है. Okay, no issues. Let me break the 2 as 1 plus 1 as 1 plus 1, क्योंकि then 2 वाला मैच नहीं होगा. Let me write it as 1 plus e power j 2 pi by 3. Okay, yeah, let me write it as, correct, 2 pi by 3 into n. Now let me break it as 1 plus, okay, जो 1 है ना, इसको लिख देंगे e power j 2 pi by 6 into n multiplied by e power minus j 2 pi by 6 into n. Cancel हुआ कि नहीं हुआ? Okay, e power x, e power minus x will be 1 only. Okay, will be 1 plus, ठीक है, ये ऐसे कर दिया, ठीक है ना, plus what? Okay, plus e power j. Now this is in 2 pi by 3, so better write it as 2 pi by 6 into 2. तो इसको भी better है split कर दो, e power j 2 pi by 6n e power j 2 pi by 6n, so that whenever you add 2 pi by 6 plus 2 pi by 6, you will get 2 pi by 3. Okay, now you are getting your answer. From the first and the third, from the second and third term, what is common? What is common? E power j 2 pi by 6n is common. Okay, that is common. So let us take that as common. So now xn has 1 plus e raised to the power plus j 2 pi by 6 into n, which is common. Okay, then e power minus j theta and e power j theta. आ गया आपका आंसर. E power minus j 2 pi by 6 into n plus e power plus j 2 pi by 6 into n. Okay, now you are getting your answer. So final answer for xn is now 1 plus e raised to the power j 2 pi by 6 into n. E power j theta plus e power minus j theta is 2 cos theta. Okay, it is 2 cos theta. So let me write down 2 here and let me write down the cos theta here. Theta given by 2 pi by 6 into n. The theta is given by what? It is given by the 2 pi by 6 into n. Oh, that should be the value of what? That should be the value of the xn. That should be the value of the xn. ठीक है? That is the correct answer for xn. Okay, so my option is 1 plus e power j 2 pi by 6n cos 2 pi by 6n, option number B. Be very careful in choosing it up. ये भी 2 pi by 6 है, so option number B it is. Correct, option number B. Good question. Okay, end में थोड़ा सा manipulation भी करा दिया, and fundamentally this is the property that you should all be knowing. DTFS coefficients are periodic. They are periodic. ठीक है? They are periodic. And actually what is their formula? यहाँ पे जरूरत नहीं पड़ा actually, but what is the formula for AK? It is given by 1 upon n summation of xn e power minus j k. इतने से नहीं रहा है. The formula is given by AK 1 by n summation of xn e raised to the power minus jk 2 pi by n into n, e power minus jk omega naught n from n equal to 0 say n minus 1. That is what you should know. Yeah, you can also note it like this. AK is given by 1 upon n into xk, where xk being the DFT. Where xk being the DFT. ठीक है? xk is known as what? It is known as the DFT. ठीक है? चलो, done है. Next question. 2023 EE2 marks question. The discrete time Fourier transform of a signal is given to you. X omega is equal to 1 plus cos omega e power minus j omega. Consider that xpn is a periodic signal of period n equal to 5 such that xpn is equal to xn for n equal to 0, 1, 2. It is equal to 0 for n equal to 3 and 4. And xpn is given by, okay, xpn is given by summation 0 से n minus 1 ak e power j 2 pi by n kn. Okay, that is the Fourier series formula again, DTFS. The magnitude of the Fourier series coefficient A3. देखो इसको अगर आप डायरेक्ट निकालोगे, it will be little bit time consuming. If you want to calculate this directly, it will be little bit time consuming. Okay, but what is the Fourier series coefficients formula just now revised? चलो by chance we just now revised 1 by n. Okay, summation of xn e raised to the power minus jk 2 pi by n into n. E power minus jk 2 pi by n into n. Clear? Okay, summation what? N equal to 0 से n minus 1. Now guys, just one small observation. Just one small observation. Okay, just one small observation. Okay, what is the DTFT formula? भाई ये तो हो गए DTFS coefficients. Okay, what is the DTFT formula? DTFT formula, x omega is given by summation of xn e power minus j omega n from n for all values of n, for all values of n. Okay, that is minus infinity to infinity, but here it is 0 से n minus 1. Okay, so if you consider a finite duration signal, okay, suppose if xn is equal to 0, okay, okay, if xn is equal to 0 for outside the interval, okay, या xn is not equal to 0 ऐसा बोल देते हैं, कैसे बोले इसको, okay, for n not belonging to 0 से n minus 1, for n not belonging to 0 से n minus 1, मतलब whenever you go outside the range 0 से n minus 1, xn will be 0, okay, xn will be 0, okay, so what is going to be x omega? X omega will now be summation 0 से n minus 1 only, okay, xn, because outside this range xn is anyway 0 na, e power minus j omega n. Okay, put, okay, omega as omega k, which is known as the discrete version of the frequency, okay, which is known as the discretized frequency, which is known as the discretized frequency. What is the discretized frequency? Omega k, we take 2 pi by n into k, because any DTFT is always periodic with the period 2 pi, so complete period divided by n samples, because signal has total length n, complete period divided by n samples into k, where k may be 0, 1, etc. up to n minus 1. Matlab these frequencies are, okay, these frequencies are in the form of 0 or 2 pi by n, और k का वैल्यू 2 रखा, k का वैल्यू 2 रखा तो 4 pi by n और एटसेट्रा, और एटसेट्रा, ठीक है, दिस इज द वैल्यू ऑफ ओमेगा के, ठीक है. इफ यू पुट दिस x ऑफ ओमेगा के, अगर इसको पुट किया x ऑफ ओमेगा के, ओके, यू गेट समेशन xn e पावर माइनस j, ओके, ओमेगा की जगह ओमेगा के, तो e पावर माइनस j k 2 pi by n into n summation 0 से n minus 1, and what is this? Summation 0 से n minus 1, okay, just 1 by n और multiply करोगे, you will get the Fourier series coefficients. That means the Fourier series coefficients ak is 1 by n x of omega k. This is the shortcut. The Fourier series coefficients are given by 1 by n x of omega k, 1 by n x of omega k. This is the shortcut. Actually ये पता होना चाहिए, but since if you don't know, I'm writing it here. So what is the value of, okay, what is the value of, okay, a3, it should be 1 by 5, okay, because period हमें 5 consider करना, we are going to extend it to a period of 5, okay, 1 by 5, okay, what I told, 1 by 5 x of omega k, okay, x of omega k. So what is going to be the omega k here? What is going to be the omega k here? Omega k here is 2 pi by n into k, that is 2 pi by 5 into k. ठीक है. What is going to be a3? 1 by n into x of omega k, that is 1 by 5 into x of omega k, which is 2 pi by 5 into k. Now x omega is given, you just have to substitute 1 by 5 into 1 plus cos omega k, कोसाइन के अंदर रख देंगे 2 pi by 5 into k. अच्छा, ये a3 नहीं है, अभी k का ही फॉर्मूला चल रहा है जनरल. I am still on to ak. Okay, cos 2 pi by 5 into k into e power minus j, omega की जगह again 2 pi by 5 into k. Now you have to just write down the values. Okay, put down k equal to 3, dear. Okay, put down the k equal to 3. So what is going to be a3? What is going to be a3? 1 by 5, 1 plus cos 2 pi by 5 into 3. Okay. Okay. 1 plus cos 2 pi by 5 into 3 into e power minus j 2 pi by 5 into 3. We have to solve this calculation. Okay, we have to solve this calculation and then come up with the answer. They are asking the magnitude. ठीक है, बाद में magnitude भी निकालना पड़ेगा. Okay, so this is 1 by 5. Okay, into cos ये हो गया 6 pi by 5. Okay, and when you take the cosine of thing properly in radian, minus 0.81. So 1 minus 0.81 is multiplied by e power minus j theta. What is e power minus j theta? It is cos theta plus j sin theta. Cos theta minus j sin theta. E power minus j theta है ना? Okay, so what is the value of sin theta for this? That is minus 0.58. तो minus minus plus हो जाएगा plus j 0.58. Okay, so this is actually turning out to be 0.038 minus 0.81 plus j 0.58. Okay, what is the modulus of A3? When you take the magnitude, 0.038 remains to be same. Root over of x square plus y square .0378. कितने डेसिमल प्लेस तक बोला है? अप टू 3 डेसिमल प्लेस. तो 0.0378 approximated to 0.038. Approximated to 0.038. चलो इसका मॉडुलस केवल मैग्नीट्यूड पूछा था ना, इसको निकालने की जरूरत ही नहीं थी. सॉरी, सिर्फ मैग्नीट्यूड पूछा है तो नीड नॉट कैलकुलेट दिस, फॉरगेट दिस. आई विल मेक इट लिटिल सिंपलर. ठीक है, निकाल लिया, नो इश्यूज. Okay, so this A3 is turning out to be 1 by 5 into 1 minus 0.81 ये आया था. Okay, into e power minus j something है ना, e power minus j theta. Okay, so A3 is coming out to be, this part is, okay, 0.038, that is what we obtained, into e power minus j theta. Anyways, we need the magnitude. So magnitude of r e power j theta is r ना, e power j theta magnitude is anyways 1 ना, so वो calculation skip कर सकते थे. तो answer is 0.038. The final answer should be 0.038. This is a very good question. Okay, 2023 EE 2 marks question. Very good question. इसलिए बोलता हूँ, all branch students, whether you are EE or EC or IN, practice all branch question so that you get more and more variety and so that you get more and more concepts to learn. Okay, more and more concepts to learn. ठीक है जी? More and more concepts to learn. So that's it, guys. Okay, so you know, if you want to have the complete syllabus coverage in the remaining time, because GATE exam is coming closer. Okay, so crash course is now live for you. Complete syllabus coverage in the remaining time. Okay, with live classes, recorded sessions, study material, practice quizzes, mock test, everything available. Okay, so you can enroll now. You can contact 924-133-333-666 to know anything about, you know, maybe the faculties, the fee structure, the timing, anything you want to know. Okay. Also, guys, at the same time, okay, you need financial assistance to enroll for any courses. Okay, just prove yourself. This Sunday, that is 1st October, starting from 9 AM. Okay, the national scholarship test for the GATE examination, okay, on the BYJU'S exam prep app goes live on the Sunday. Okay, appear, and based on your performance, you can get up to 90% scholarship on the preparation courses. And also, guys, this coming Wednesday, okay, 27 September at 7:30 PM, Richa ma'am is going to bring you a free live interactive workshop, because only around 4 months are left for the examination. Okay, that last 4 months are really to capitalize whatever you have done till now. Although you are going to still study more, still new topics will be there. Okay, but it is very important phase where you have to capitalize, learn new topics also, and concentrate on the old also. Okay, so last 120 days, what should be your preparation strategy? Okay, on the BYJU'S exam prep app, a free live interactive workshop at 7:30 PM, Wednesday, 27 September. Okay, that's it, guys. I'll share you the PDF of today. Let me also tell you the PDF password in that case. PDF का password रख लेते हैं क्या? PDF password for today is frequency. very much related to some of the questions today. Okay, I'll share you the PDF in my Telegram group, and the password, it is going to be password protected and having the password of frequency. If it is not seen right now, it may be updated trail mail. Every subject will be there in the course. Every subject is going to be there in the course. Okay. Okay, so I'll just share you the link in a while. So you can join. If you're not there in the Telegram group, you can join using the link right there. Okay, and the password will be frequency. That's it from my side, guys. Bye bye, good night, thank you, stay safe and take care. Now see you on Wednesday onwards. Okay guys, bye bye, thank you, stay safe and take care.